Del, I've tried everything. I've written SOS in the sand, I've tried fires. I don't think we're ever going to be rescued.
I know. This is why I didn't want to go on that company happy hour.
If I only had my phone, I left it on the boat.
Well, what good would that even do? It's not like anyone could find us.
The new 5G has NTN, or non-terrestrial networking. You can connect your mobile device right to the satellite and get reception almost anywhere. We could text or phone somebody.
Oh, well, try mine.
You've had your phone all this time? I can't believe it.
I mean, yeah, I gotta keep my Wordle streak, man.
I'm gonna text for help.
Okay.
We need help. Use our GPS coordinates to locate us. Come as soon as possible. We have to shoot Frequency Matters.
Can you have them bring some water, too?
And bring some water.
Thanks.
Okay.
This is Coast Guard Bravo 4. We have visual on the source of distress call going in for rescue.
Did you guys call for help?
Yes.
Thank God you had your cell phone with you so you could reach us.
Welcome to Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle, here with my co-host Del Pearson and special guest Joe Ducey, Senior Digital and Marketing Communications Manager at Infineon Hi-Rel. As you can see, this is our annual beach edition. We're here on Plum Island in Newbury, Massachusetts. So welcome to the show, Joe.
I can tell you, as I told you before, I've waited all year for this to happen, and this is like a bucket list item for me. So I am really excited to be actually part of it. So thank you very much for inviting me.
Awesome. So in this episode, we're going to take a look at our July AI software and test issue. And it has a very good cover story. It's the first I've seen in this is high volume OTA testing with millimeter wave antenna and package modules using ATE test equipment. So Avantest looks at using standard infrastructure to do high volume testing of millimeter wave OTA modules. So it's kind of the first one I've seen. So that's a good one to take a look at. So Del, what do we have for technical features?
We had two great technical features this month. We had Keysight on simulation and RF EDA, and then we also had Times Microwave talking about the advantages of distribution in the RF industry. So can you tell us about some of the product features? Yeah,
we had two of them. So Siglent had their first wideband IQ emulation and analysis for debug and design. And we also had Rohde & Schwarz, who did the improvements to their phase noise tester, which has kind of been a golden standard in the industry. Del, how about tech briefs?
We had three great tech briefs this month. We had some tech briefs information from Rosenberger and RFMW on some of their new interconnects going up to 110 gigs. Then we also heard from OptM and Remcom on some more simulation software. So Pat, tell us about why we have Joe here today. And
it fits in really well. We had the introduction about how you can use NTN to connect directly from mobile devices to satellites. Mm-hmm. It's kind of a big trend that's just emerging now, and that's being done and rolled out. And Joe, I know that Infineon's very involved in the satellite and space market, so maybe you can tell us about some of the trends that you're seeing there.
Absolutely, yeah. As you said, like I said, Infineon has been in the space business for right now. It's actually over 50 years, so there's a lot of experience there. But as far as the trends moving forward, it's really not a new trend. It's actually something, but it's a trend that's accelerating, and that is global connectivity networks in satellites. So what we're seeing is there's really three foundational pieces for kind of accelerating the satellite networks. And that's one is demand, obviously, because there's increased demand with mobile phones, like you said, with the NTN. Then there's obviously the advancements in technology that we're seeing. I mean, because of things like the Versal ACAP chip that's being used on a lot of these new satellites is kind of the foundational processor now because of all of the new capabilities with AI. So that's important. But really the thing that's driving the acceleration is the reduced cost. Because if you look at it, and this puts it in perspective, in 1965, a Delta E rocket that was pretty much used to blast payloads into space, it would cost $100,000 per kilogram for the payload. So just keep that in mind. Now, fast forward to today, where a SpaceX Falcon Heavy rocket can launch a payload for $1,500 per kilogram. Wow. So it's an order of magnitude. It's unbelievable. So what that's doing is that's allowing other private enterprise to get involved into this, because normally it was usually the government that was funding this in millions and millions of dollars. But nowadays, because the price point's so low, now these private entities are actually getting involved. Like, obviously SpaceX with Starlink, and then you've got Blue Origin. Now you've got Amazon with Kuiper. So all of these small private enterprises are getting involved, growing these kind of low Earth orbit satellite networks.
Awesome. And we keep hearing about, rad tolerant or rad hard parts, and I know that Infineon has been working on those. Can you tell us a bit more about that technology?
Oh, absolutely. It's funny because, outside of the space industry, rad tolerant and rad hard, they sound like new wave band names. But in the space industry, it's actually ubiquitous. Everybody knows what rad tolerant is and what rad hard is. And for rad hard is basically short for radiation hardened. And rad tolerant is for radiation tolerant. So what I'll do is I'll talk about rad hard first. And basically rad hard has been around a longer time because when governments and other companies were doing, like NASA, for instance, they were doing space launches, they would actually develop rad hard products because these products were designed to go outside of the protective orbit of Earth. And what happens is as you go further away from Earth, you get higher levels of radiation. And that radiation obviously is very harmful for electronic components. So what happens is, so as you go further out, you need rad hard components to survive for extended periods of time for missions. And what rad hard does is it introduces a lot of shielding and a lot of unique structures and capabilities in the semiconductors and the substrates they use. But it also for rad hard products, there's a lot of upscreening. So there's a lot of quality and additional manufacturing processes that go into it. And because of that, you can guarantee that those products are going to be reliable in space. But the downside to rad hard is the fact that it takes longer to develop them, takes longer to manufacture them, and they're very costly because you have to ensure that those are going to last for 10, 15, 20 years. And actually even longer because you have like Voyager 1, which launched in 1977. It's still working. It's still sending back data. So so it's very difficult to get out to repair a satellite, and it's very costly, especially if it's out in deep space. You're not going to do that. So people will invest heavily in the beginning to make sure everything works. But if we shift and we go to rad tolerant, that actually fits better with what's going on today with these low Earth orbit satellite constellations. Because what happens is these low Earth orbit, as the name says, is they're hovering just outside of the Earth. So the levels of radiation are much lower. Your total ionizing dosage is much lower than it would be for rad hard. But by doing that, rad hard tolerance still offer a level of protection from radiation, but they're not at the level of rad hard. But again, the nice thing about that is they're cheaper to manufacture. They're faster to manufacture. And with all of these different satellites going up in hundreds and thousands, every time you turn on the TV or you look online, Starlink's launching another Falcon with, they're launching another 200 satellites. So to keep up with that volume, you need to be able to have something that is like an automotive grade product, but has a slightly higher screening level to it. And that's what rad tolerant does. So it really allows manufacturers to keep pace with all of these new, all these people launching satellites. So it's really, it's something that we need to do because you can't use rad hard in low Earth orbit. It's just too costly and it just takes too long. So it doesn't fit the model. And like I said, Infineon has been doing this for over 50 years, and we're on countless number of space missions, ranging from Voyager 1, Voyager 2, the Mars rover, the Perseverance rover, and things like the Hubble telescope and the James Webb telescope. So the nice thing is that we have a lot of heritage and we have a lot of experience in that area, but we're actually taking that rad hard experience and we're transitioning that over to the rad tolerant industry. So, so there's a lot of crossover and there's a lot of benefit to that.
Very interesting evolution.
Yeah, absolutely. Yeah.
And so turning to events, the numbers are in for IMS 2025. They had about 8,000 registered attendees on site and about 500 companies exhibiting. And this was in San Francisco, which usually sets a record every year. So I think it's a little bit mediocre on that level because DC had more exhibitors and about the same amount of attendees. So it's in Boston next year, our hometown. So hopefully they'll do much better then.
That is the hope. We'll
I would
see
love
how
it. Yeah, it's
goes.
great to be back in our hometown. It always does well in Boston, though. Boston's a hub, and with all the technology around here, I think it's a good draw.
Absolutely. And you'll be gone next week. Can you tell us about that?
Yeah, I'll be heading to Ottawa next week to do the Antennas and Propagation Society Symposium, and I'll report back in our next episode.
Sounds good. And don't forget your phone. I know you won't be over the ocean, but I won't be there to help out. I'm going to be here holding down the fort pad.
I'll keep that in mind.
All right. Thank you. Well, I think that wraps up this episode. Thank you again for joining us, Joe.
Well,
It's
thank
great
you
to
for the
see
invitation. It's exciting.
Absolutely. This episode is sponsored by RFMW, so please consider them when you are purchasing your next power or RF supplies. I think that wraps up. Thank you for joining us today. As a reminder, if you are a member of the industry, a subscription to Microwave Journal is free, so please log on and get your subscription. All right, thank you. I want to go on that company outing. Ugh.
Well, I forgot what else. Don't go in the water. We don't need. He's so determined to get in the water. I'm like.
I got one line, I can't do it.
I didn't know it was a college or small.